So, good day everyone! Welcome to our presentation about understanding data structures and algorithm, presented by BENSURTO Andrew, DACUMA Joanalene, Cafe Lizandro, LABUTIN Arjay, and SABLAN Tristan Paul. The objective of this presentation is to explain data structures algorithm in a simple way. Understanding DSA might be difficult due to complexity of its topic and other terms in programming. Secondly, is to help non-technical people to understand the basics. So some of you might just discovering what is DSA. Lastly, to show why DSA is important in software development, especially to IT students, how DSA is crucial in creating software application development, such as calculator, storage system, and developing games.
A data structure is simply a way of keeping data organized so it's easier to use and understand, just like how you arrange your things at home, books on a shelf, clothes in a cabinet, or files in folders. Data structures helps computers store information neatly. When data is well organized, it can be found, updated, and used faster and more efficiently. For example, a list of names helps you quickly look for a specific person. A table of student records keeps important details in orders, and a stack of books show how items can be added and removed one at a time. This simple idea helps computer work smarter and make program run smoothly. This slides helps us understand data structures by comparing them to things we see in everyday life. Using familiar situations make these concepts easier to remember and less intimidating. A queue is like people waiting in line. Whoever comes first is served first. A stack is similar to stack plates, where you take the top plate first before reaching the ones below. A tree represents relationships and connections like family branches growing from one root and spreading out. Lastly, family shows how generations are connected, similar to how data elements can be linked together. By using these simple analogies, data structures become more relatable and easier to understand, especially for beginners learning how data is organized and managing in computing. An algorithm is simply a set of clear steps you follow to get something done. In everyday life, we use algorithms all the time without realizing it. Whenever you follow instructions, you are already using one. For example, cooking rice requires doing things in order, measuring the rice, adding water, and turning on the stove. Logging into Facebook also follows steps like entering your username and passwords before accessing your account. In computers, algorithms work the same way. They guide the steps by step so tasks are done correctly and efficiently.
Example algorithm: linear search. Linear search searches for a value one by one in a list. This slide explains linear search, which is a simple way to find something in a list. Linear search works by checking items one by one, starting from the first item. For example, if you are looking for your name in the attendance list, you read each item from top to bottom until you find yours. The steps are very easy. First, start at the first item. Next, compare each item with that you are looking for. If it does not match, move to the next one. When the correct value is found, the search is stopped. Relationship between data structure and algorithm. Data structure, where data is stored. Algorithm, how data is processed. This slide shows the relationship between data structure and algorithms. A data structure is basically how information is stored and organized, like boxes, folders, or shelves, where you keeping things. An algorithm, on the other hand, is the step-by-step process or instructions on what to do with the information like searching, sorting, or updating it. Real-world analogy. Example: library system, bookshelves, data structure, searching for a book, algorithm. This slide uses a library as a real-world example to explain data structure and algorithms. Think of the bookshelves as the data structure. They organize and store the books so they don't get messy. The algorithm is how you search for a book, like checking shelf by shelf or following the labels. In the same way, computers work better when data is organized properly and right steps are used to find information.
The pseudocode describes a simple algorithm to find a specific item within a list. Explanation: for each item in list, this loop iterates through each item in the given list. If item target inside the loop, this condition checks if the current item is equal to the target item we are searching for. Return found. If the item is equal to the target, the algorithm immediately return found, indicating that the target item has been found in the list. Return not found. If the loop completes without finding the target item, the if condition is never met. The algorithm returns not found, indicating that the target item is not in the list. Why data structure and algorithm are important? Make program faster. Efficient algorithm and suitable data structure drastically reduce the time it takes for a program to execute. For example, using a hash table for quick looks up instead of a linear search in array. Reduce memory usage. Optimize data structure, use memory more efficiently, allowing programs to handle larger amounts of data or run on devices with limited resources. Choosing the right data structure can minimize redundant data storage. Solve complex problems easily. Data structure and algorithm provide framework for breaking down complex problems into smaller, more manageable parts. Well-known algorithms can be adapted and applied to a variety of problems. Improve coding skills. Understanding data structures and algorithms enhance your ability to write efficient, maintainable, and scalable code. It fosters a deeper understanding of programming principles and problem-solving techniques. It essence a solid foundation in the data structures and algorithms is crucial for developing high-quality software that will perform well in addressing complex challenges effectively.
So, moving on to the real-life applications. Real-life applications show how this concept is used in everyday technology. Social media uses it to manage posts, likes, and messages. Navigation apps rely on it to find the fastest routes and track locations. Online shopping uses it to process orders, payment, and recommendations. Databases use it to store, organize, and quickly retrieve large amounts of information. So, this summary highlights the importance of understanding key concepts such as data structures and algorithms, which help organize data efficiently and solve problems effectively, while also emphasizing best practices like code efficiency and readability to ensure programs run smoothly and are easy to understand, maintain, and improve.